Let's go. Okay, here we go. Why is this, sorry, it's frozen. Why is this an optimization problem? Who sees a primary? I do. Do you? Louder. Maximum. I don't see the word max, though. Greatest. And closest. Uh-oh, isn't that max and min? Who? Got it. So distance formula. Oh, you got to be kidding me. D equals the square root of something, something, something. Pause. I'm not going to show you over there. Well, I can show it on the video. That's BC stuff. Anyway, coming back up here. Haven't we been talking about in section 3.7 the difference between a change in y versus a dy? Right. Change in y goes between two different y's of a curve, and it goes between two different y's of a tangent line, right? Which is why the derivative is defined to be a slope, because it's a change in y over a change in x of a tangent line. Why am I saying that? Hold on. Isn't the distance between 2 points just 2 points connected, which makes a right triangle? So Pythagorean theorem is the distance formula? Change in y squared plus change in x squared, square rooted. The distance formula was never meant to be hard, but why am I doing the change of x, x minus 2 squared, and the change in y minus 0 squared? How do I know that? It's always to the point 2, 0. Isn't that like a constant, something I can always depend on? Kind of like related rates I can plug into from the beginning. That's my primary. Who's my secondary? Didn't they tell me? A clue? What are we reviewing right now? In some ways, optimization. Wait, pause. Tricky name. All it means is what kinds of problems. Max min. How do we find max min? Critical numbers. And check for endpoints. If no endpoints, okay, a sign chart. If endpoints, uh-oh, table. What's the one piece of information we haven't really done? This would be black, right? Wants me to find the point, x, y, for whatever's going on, right? But what else haven't I used? Why am I doing green?
Domain.
They gave me endpoints. We'll get back to the endpoints in just a second, but that doesn't affect what I'm supposed to be doing. I'm supposed to be finding a max or min, and to find a max or min, I want a derivative. But to find a derivative, don't you love yourself? What am I going to tell you to do first? Simplify. So D is equal to, okay, come on. We're in calculus. What are we not going to do? Kill puppies. Because we're going to do what? FOIL. X times x is going to be x squared. Negative 2x and negative 2x is negative 4x. Negative 2 and negative 2 is positive 4. Cannot be x squared minus 4. That factors to be x plus 2 and x minus 2. That doesn't work. Plug in a square root of x minus 0. Still square root of x squared is just x. So D is equal to the square root of x squared minus 3x plus 4. What's it time for? I mean, we could try to factor. It's not going to be a perfect square, so it won't simplify anymore. What's it time for? Derivative. Derivative. Don't I have a u to the 1/2? Can't I make that 1/2 u to the negative 1/2, which makes the square root go down? But what can I not forget, my bunny killers? U prime. We'll see how this goes in this class. Which equals 2x minus 3 all over 2 square root of x squared minus 3x plus 4. So what do I have? 2x minus 3 equals 0. And how do you do this equal to 0? Divide both sides by 2. Still 0. Square both sides. Still 0. So who am I really looking at? How important was it in chapter 3a to be able to factor? Extremely. Guess what some of us still have as a weakness from Algebra 1? Factoring. That we didn't get solid before the test, which I'm on the back page of, so I've graded the majority of it, just not the 14 identifies. Hopefully we'll get it back tomorrow. How sad is it if you can do all the calculus, but you can't factor? Some of you need to learn how to factor something like 2x squared minus 5x minus 12 and not be scared of it and be right every time. And if worst comes to worst, can't you always do quadratic formula? X equals negative b plus or minus square root all over. Even if you can't factor, you can always figure out what the zeros would be. And from the zeros, let's just say the zeros are, sorry, hold on, I should think about this. It's going to be 8 and 3, so it's going to be x minus 4 and 2x. Oh, sorry. Yeah, x minus 4 and 2x minus 3, right? So the zeros would end up being 3 halves and 4. Nope. Lo siento. Negative 3 halves and 4. And from those negative 3 halves and 4, you can say, oh, it must be x minus 3 halves. So x plus 3 halves and x minus 4. Anyway, that was a lot of math in my head, and I might have gotten the signs off. But from quadratic formula, you can go backwards to factors if worst comes to very, very worst. Why am I bringing up factoring and bringing up something like you have to be able to factor trinomials in calculus? Because some of you, it's not a strength, and it's going to mess you up. How much stuff is online for you guys to learn how to factor? Need it for Algebra 1, need it for Algebra 2, need it for pre-cal, need it for calculus, need it for, oh my goodness, everything. So, if you don't know how to, what again?
Factor.
You should learn how to.
Factor.
And if you're afraid you don't know how to,
Factor.
in a way that you will always
Factor.
correctly, then you better come in and help. Give me a chance to teach you how to
Factor.
perfectly every single time, because I am going to force you to over and over and over and over again until your eyes are popping out, and that way you'll be able to perfectly from here on out. Some of you, when you see your test, you're going to be like, wasn't homework 19A and 20A and 21 and the practice test and the review all supposed to force you to, when you did derivative simplifying, derivative simplified, stop. Sorry. Why? Don't let the silly stuff mess you up on the calculus. And don't let the AP, whether multiple choice or long answer, take away your points that you know how to do because you can't do basic stuff. Should you feel ashamed if you can't?
Factor.
No. But if you don't work on it, that's the shame. Does that make sense? Okay. Why am I saying that? Oh, because what am I about to do? I'm about to factor. So I'm going to go ahead and say, oh, this is an easy one, right? It has to be an easy one. So therefore, and therefore my zeros are 3 halves and x equals 4 and negative 1, right? Good. It doesn't work. Wouldn't negative 4 and a positive 1 make a negative 3, but also make a negative 4? Is this an easy to factor one? So try to find something harder? No. Factoring isn't working. So use your quadratic formula. My ones that would just give up. X equals negative b. Oh, I squared it. Lo siento. X equals negative b plus or minus.
B squared minus 4ac all over 2a.
Oh, just kidding. Why?
That was so
9 minus 16 is a negative 7. What's the square root of a negative?
7.
Parabola up. Does it have any zeros? No. What does that mean? Well, forget him. I only have 1. Why am I going to draw your attention really quickly back here?
Domain.
when you have endpoints and when you have a critical number in between, how do you test for absolute extrema? What am I making? A table. Why? That's how you test for absolute extrema of a continuous function within a closed interval. I have an endpoint, I have an endpoint, I have an endpoint. What am I plugging it into? Distance. How high is your y? Whose y will win? Well, plugging in 0. Don't plug it in there. Plug it in here. 0, 0, 4 square rooted is 2. Careful, right? Not the derivative, the original. 0, 0, 4 square root of 4 is 2. P.S. Plug in 3 and 9 minus 9 is 0 plus 4 is 4. Square rooted is 2. Oh, they tie. For what? I don't know. Let's keep going. 3 halves. Ugh. 9 fourths minus 9 halves. Oh, 9 fourths minus 18 fourths. Negative 9 fourths. Plus 4 plus 16 fourths. Negative 9 fourths plus 16 fourths. 7 fourths. Square rooted? Ugh. Well, it's not quite 2. Square rooted, definitely less than that one. So guess what? Those two tie for max. And this one has the min. That one's a max, that one's a max, and they're tied. And that one's the min. What are they asking for? Find all points, x's and y's. Oh, that are closest. Closest would be minimum distance, right? So closest is going to be that weird square root of 7 over 4, which, yes, would be root 7 over no root 2. Square root of 4 is 2. Why am I doing this twice for the y value? It is a point, and where am I getting my y from? Isn't y the square root of x? So if that's x, then that's y. Do you like it? No. Do I like it? No. Could I rewrite it as a fourth root? A half to a half? Power to a power you multiply? Yeah. But sticking it to the man, that's right also. If you want to see it in a prettier form, I guess it could be square root of 7 over 2, and then the fourth root of 7 all over the square root of 2. Ugh, it's kind of gross, but that's another way of writing it. So that's the closest point. Who am I still missing? The farthest, or the max. Good, so the farthest point. Farthest distance, not furthest. Furthest in. Farthest distance, I have a tie. Why am I not putting 0, 2, and why am I not putting 3, 2? It's not the distance, that's the y. Who's the y? Square root of 0 is 0, and square root of 3 is root 3. Dun, 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 dun. Colby, I'm coming right back to you. Let me freeze the screen for 1 second for people who are still finishing. I'm going to go grab number 13 if my Firefox isn't frozen and refusing to work, which is really sad. Well, never mind. Go ahead, Colby. What's up, bud?
Why didn't you put in 3 over 2 for the x replacement?
Oh, because I'm dumb and I put in the distance and not the x value. Thanks, Colby. I think I did that in period 1 and no one caught me. Good job, bud. Because I think I just repeated that mistake because it seemed awfully familiar when I did it. Why is Colby getting on me for plugging in the 7 fourths? That's not the x. What's the x? Which could have also been 3 halves. And what would that be? Square root of 3 over square root of 2, square root of 3 times square root of 2, square root of 6 over 2 if you rationalize it. Something like that. Not sure which answer they would give you. It could be either. Thanks, Colby. Appreciate it. Number 13. Turn in your homework spirals. Let's get ready to start grading, but let's start with number 13. Wait, which was a video in your homework, so it shouldn't have been bad. Oh, awkward. The directions asked for minimum distance, I think, and did not give you a closed interval. Hence, sign chart, not a table. Minimum distance for number 13. We're back in section 3.6 for 1 second. This is your either final homework problem or you did it in order because you're cool like that and didn't skip it like I told you to. But number 13, sorry guys, my Firefox is frozen. I reloaded it. It's still frozen, so you're nice online textbook is not working out right now. But that's okay. Give me the function. Who's your f of x for number 13? Thank you. And what's the point you're trying to find the distance to? Does it make sense now from what I just did that I'm going to go ahead and do d is equal to the square root of x minus 2 plus y minus 1/2 squared? And then I'm going to change my pen to blue to say, hey, who are you? He's my clue. And my clue, I'm going to go ahead and plug him in. I love myself. I'm going to FOIL. Okay, now it gets a little awkward. Because now it's going to be x squared minus 1/2 squared. X squared times x squared is x to the 4th. Minus 1/2 x squared minus 1/2 x squared is minus 1x squared plus 1/2 times 1/2 is 1/4. Ugh. That's right, I still love myself. Cross off the x squareds. Simplify the 4 plus 1/4. 16/4 plus 1/4 is 17/4. So x to the 4th, descending order, minus 4x plus 17/4 is my d. What am I supposed to do with him? Derive, because I'm looking for critical numbers, right? So I can go ahead and say d prime is equal to, all right, let's see, bring down the 1/2, negative 1/2, I'll get back to that in a second, times u prime. Ooh, I see a 2 and some 4s. I bet I can reduce something, 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 something. I have x to the 4th minus 4x plus 17/4. Long story short, pitchfork. If you want to make your life a little easier, I guess you could reduce as long as you do it to everybody. You can't just go doing it to one term and not the other. When you have subtraction or addition, you'd have to factor out a 2. I can solve for him pretty easily. Wait, what's the derivative of negative 4x for my u prime? Derivative of x to the 4th is 4x cubed. Derivative of 4x is just 4 with that little negative. Lo siento. Add the 2, divide the 2. 1, cube root it. Oh, x equals 1 is one critical number, setting him equal to 0. Setting him equal to 0. You just said factoring, but that's gross. I wish it was a squared. We could do a little trinomial action, but he's not a squared. Well, you're not going to like what I'm about to say. If you had your calculator, you would like this. If you had your calculator, you could graph this guy. Because square both sides, you still have the underneath has to be a 0. A square root will never make a 0 by itself. That has to be 0. If you graphed him, guess what? He doesn't hit the axis. Does he have any zeros? How could you know that by numbers? Well, you could experiment a little bit. There are these things called Descartes' rule of signs and the upper and lower bound rules from last year that we barely touched on. Or you could do things like plugging in 0. The lowest x can be the lowest positive, and it's still a positive number. Plug in a negative number. Maybe it'll go negative, showing a crossing of the axis or a 0. But if I plug in a negative, that's a positive. A negative times a negative is a positive, but that's still positive. Well, if 0 makes a positive and all negative numbers will make a positive, then let's check the positive numbers. Let's try like 1 or 2 or 3. 1 minus 4 is negative 3. Negative plus something more than 3. Positive, not 1. 2 to the 4th is going to be bigger than 4 times 2. So for 2 or 3 or 4 or 5, this guy does not have enough to make it negative. How about 1/2? Fractions are where weird things happen. 1/2 to the 4th is 1/16 minus 8. Sorry, 1/2. Minus 2. 1/16 minus 2 is, I don't know, negative 1 and something 16ths. But that's 3, so it doesn't matter. Still positive. This guy seems like he's going to be positive no matter what. Yeah, he has no zeros. I know it's not a great way of doing it. I know the graph and seeing it not hit the axis is a definitive way of doing it. Long story short, the AP wouldn't ask you one by hand that you would have to do that's that difficult. But anyway, our critical number is 1. How about endpoints? No. That was your point. No. So what's our domain? Oh. Imagine I'm writing in green. All real numbers. X can be anybody, I suppose. The directions don't say anything. Did you write down any restrictions? I remember from period 1 there were none. Huh. Side chart. It all went well. Minimum distance is what they asked for. It should be a negative then a positive. Let's try it. Plug in 0. 0 minus 4 is a negative. 0, well, we just talked about. That's positive. Negative over a positive. Oops, that's supposed to be an arrow. Plug in 2. Yeah, it's a positive over a positive. Hey, guess what? Where's my distance minimized? Careful. Does it ask for a point or an x value? Did you guys write it down? You should have. Point. Uh-oh. So I care about the distance. Let's plug into D. I care about the y, so let's plug into y. What's 1 squared? The distance is minimized at the point 1, 1. All right, cool kids. Section 3.6 is officially done. If you want to hear better explanation of that, go to the video. Maybe it's better on CalcChat. But for right now, section 3.7, isn't that where we technically are? All right. Let's grade this guy. The book is frozen, but the homework answers aren't. Number 6 had you doing one of those table-y plug-in thingamabobs, and I think so did number 3. What was it asking for? Plug into the function with a calculator and plug into your tangent line. Probably with a calculator too. So you had to make your tangent line. Y minus y1 equals f prime of 1 times x minus 1. Y minus f of 1 equals f prime of 1, x minus... Oh, I apologize too. My bad. I didn't look. But the nice thing is they gave you the stuff. Okay, y minus steal the y equals x minus steal the x. Take the derivative of... Ooh, did you guys remember the derivative of log base b of x? This is just change a base formula. Take the derivative of ln, 1 over x, but add in your ln of b. That's the derivative rule. Did you guys hear period 1 kids talk about how an inverse tangent randomly showed up on their test last time? You're supposed to know your derivative rules. Forever. And ever. Okay. What were they trying to show you? At the point of tangency, what's true about the tangent line and the function? They're the same. As you go a little bit off, though, they're really, really close. What? They're the same. Nope, go more decimal places. They're not the same, but they're close. But what happens if you get even farther off? They're going to start to diverge. Same thing the other way. The table was meant to show you, hey, they're the same at the point. They're really close when you're really close to the point, but eventually they will start diverging or going apart from each other. Number 10, delta y, using a calculator. Having to plug in your x, having to plug in the new x, which is delta x away from 2 plus 0.01 is 2.01. Plugging into the function, ugh, that's gross. Exactly, calculator, okay. But what's so much easier? dy, taking the derivative with dx and then plugging in the x and plugging in the y and saying, I know 8 and 4 is 32 and move the decimal places 2. Hey, look, they're close. I can do that by hand, whereas that's really hard. Number 14, did you remember number 1, your rule for cosecant, and number 2, your u prime? Did you remember number 1, your rule for cosecant of u, negative cosecant of u, cotangent of u, but also your u prime, which is 2. Then multiply the dx. Number 28, what was the mistake? U prime. You think I'm trying to make a point about u prime? Not just u prime, did you remember your product rule? Second d first, there he is. Plus first d second, uh-oh, the derivative of cosine of u is negative sine of u times u prime. Now pause with your colored pens. Make a correction if you did not put parentheses around the derivative before the dx. Ooh, you would technically not be right if you wrote just dx next to this guy with no parentheses to show it would distribute to both. Be careful. You guys fixing it? Color pen, parentheses? And last but not least, didn't we talk about this one together in class? 900, the slope is increasing. Since the slope is increasing, the change in y, the change in profit will be greater. could also talk about the concavity being up, which means the slope is increasing. You can talk about, instead of saying the slope is greater or higher, you could say the rate is greater or higher, because rate and slope are synonymous. All right, questions on odds or evens for the tangent line differentially homework. Victor?
41.
Yeah, period 1 didn't like 41 either. Anything else besides 41? 51? Okay, I'm going to get a book out real fast since my poor little Firefox is very unhappy. What are we in? Section 3.7? Okay, as I get set up to talk about 41 and 51, sorry, last homework questions. Going once, going twice. Sold. Keep your homework spiral open if you need these answers. But as I get them ready to go, what do I want you to be doing? Making sure you have the notes from yesterday, maybe even the example from yesterday, and see if you can solve the new example for today. Keep your homework spiral out. If you need these questions, I will go ahead and get the questions ready to go for you for me to answer. But have your notes ready to go for me when I come back. 41 and 51. Oh, I like 41. And I like 51. Yeah, Jack. Who writes similarly to Jack? Dean, maybe? How many pages of notes did you take on L'Hôpital? Just like one? Yeah. Above this, there were 2 slides. Well, here, I can show you real fast. Let me unfreeze it. It was kind of more concept-y. These were the first 2 slides, so it was a lot of, which you could have squished in. And then we had 1, 2, 3, 4 examples.
Okay.
Is that cool, kind of? Thanks, bud. Few steps, though. But first of all, excuse me, number 41 gave us the 4th root of 624 and said approximate. And we're like, wait, this is what I did in class with the cubed root of 128, right? You have to think about, we don't know that guy, but who do we know? We know if you plug in, no, not if you plug in 5. You get out 5 if you plug in 625, right? 625 is the 4th power of 5. Not everyone would have known that. Like, well, 4 and 4 and 4 is 1, maybe you wouldn't have known that. 3 and 3 and 3 is 27. 4 and 4 and 4, well, 16 and 4 is 64. 5 and 5 is 125. Wait, we're doing 4th powers. Sorry. 3 to the 4th is 81. Tack on another times 3 to 27. 4 to the 4th is, well, 64 and 4 is 256. Has to do with computer numbers, like the size of RAM and different measurements like that. Anyway, 256 is 4 to the 4th. 256, 512, 1028. 512 is a power of 2, sorry. Binary? Makes sense. Anyway, coming back. So 256 is 4 to the 4th. 555, 125 and 5 is 625. Anyway, long story short, we know one that's super, 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 super close. So what do? We say, booyah. Let's use him to make a tangent line. Take a derivative of the 4th root would be 1/4 this guy to the negative 3/4. Negative 3/4 says denominator cubed 4th rooted, but we're not doing f prime of x in a tangent line. What are we doing? F prime of not the function. Who are we cubing? An x? No. A c. Why does it make it better? Because I know him. Y minus 5. Because well, of course I know him, 625. And how on earth are we supposed to know him? Because we know 4. That's easy. And don't we know what the fourth root of 625 is that we could then cube? 1/4 times 3 is the same thing as 3 times 1/4. I can do the fourth root, then the cubed, or the cubed and then the fourth root. We just said that's 5. 5 cubed is 125. 125 times 4. Hey, 4/4 is 100. 400 plus 100 is 500. 1/500th. And what am I going to plug into said tangent line? Said tangent line, which is L of x or T of x. Add 5 to the other side. 5 plus 1/500th. Who minus 625? Who I'm trying to find. So go plug him in and say, oh, sweet. Which leads me to the fourth root of 624 is approximately, well, 5 minus -1 minus 1/500th, aka 499 over 500. What's the decimal? Go plug it in somewhere. But it wouldn't quite be 4 point. I mean, it would be very small. You're totally right. Like it's barely 1/5 is 0.2, so it'd be 0.002. Is that right? 1/5 times 1/100, 0.002, something like that. Which would be 4.998 or 4.9998, something. Long story short, there you go. There's the approximation. Number 51 was kind of similar, but kind of different in that it also asked you to do. Oh no, it wasn't a linear approximation. It was just a differential. You guys just didn't like taking his derivative, you silly goofs. Who was he? He had an ln. That's even easier than log base 2 of x. Y is equal to x squared ln of x. Come on, cool kids. What do you see in the middle? Isn't that a product rule? So if I need to find dy, remember dy is the derivative times dx. The derivative is second. D first plus first, d second. Ugh. Which, I wonder if they would simplify. The answer is yes. X squared over x is just x. Hey, green trick. What do you see in common? Do I have to put a bracket? I guess you could, but technically it's all nice and multiplied. You're okay. I mean, if they really wanted to, I don't remember what the multiple choice answers are. Could you bring the 2 up just from the pre-cal properties of logarithms? I guess if you really wanted to. I don't know if you do want to. Do any of these match? Yeah. Somebody does? What's the final letter? Wasn't it a letter? Wasn't it a match? E? A? A. Hold on. Let's go look at what the answer is. Maybe that was the hard part, not taking the derivative, but making it match. What happened? I heard different things. You guys should all have the same thing, right? A is 2x ln of x plus x. Oh. Dun, 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 dun. Never mind. No, simplify. Oh, well. I like the green trick, but I guess they didn't that time. Okay. Actually, I understand why, but you guys probably wouldn't. All right, cool kids. Let's get rid of him. Homework questions done. Let's get rid of him. This poor little Firefox is just not doing anything. I don't even know how to. Okay, well, that's okay. Here we go. L'Hôpital's. What did I tell Colby a second ago? Is my point right now making sure that you can give me a nice, perfect, clear, able to be contested defense for why the answer is what it is with L'Hôpital's? No, you just need to learn L'Hôpital's first. How to show the work in a way the AP guys won't question us later. But for right now, I'm just going to change a little bit of what I do and how I do limits. Just a little bit. For instance, wouldn't I tell you to start this problem the same way I tell you to start any limit? With plugging in? Yeah. don't I usually say equals, and I just leave the equals there, and then I put a 0 over 0? Why? Because I know my unit circle. And 0 minus sine of 0 is 0. And 0 cubed is 0. Anyway, wouldn't we say equals? Here's the dilemma with the AP, guys. Does the limit actually equal 0 over 0, which is an undefined number? Maybe, maybe not. We don't know. Hence why technically every time we say equals, it's a little illegal. Now pause. Every limit problem except for L'Hopital's is going to be a multiple choice answer. Doesn't matter then if you put equals 0 over 0. It's multiple choice. No, they won't know. They won't see. They don't care. Okay, so anyway, long story short, 0 over 0. Okay, let's do some of the old-fashioned stuff. Let's go ahead and factor. No. Let's go ahead and multiply by a conjugate degree test. Let's L'Hopital it. Remember how we would do kg? Now we're doing LH. No stress, no panic attacks, no need for the hospital. I mean the hospital rule. Anyway, so L'Hopital. Any Frenchies? P.S. L'Hopital. It's a guy's name, not a hospital. Sorry, not a L'Hopital in French as in the building. But there should be an accent above the O. There should be an accent above the O. Grace and someone this morning were debating what the actual accent was called. It sounded snazzy when they said it, but I definitely was not going to remember it. No, it's like a little housey thing. It's like a little, it's like a carrot. Can it be like flat too? Anyway. That thing. Do you need to put an accent if you put LH? No. Pause. Make sure everyone in your group is awake or else it's awkward. Okay, so equals. What does L'Hopital say? Now, pause. If we were doing like an actual proof, we would need to say 0 over 0 or indeterminate somewhere in some way, shape, or form. And we'll get that down in time, don't worry, for the AP, but not stressing about it right now. But what's the other if? We would also have to talk about how he's differentiable. His derivative exists everywhere and how he's differentiable. Technically, we have to say, hey, those two are differentiable. It produces a 0 over 0, so therefore, but anyway, what's the long story short? 0 over 0 differentiable, I can take the derivative of the top and the derivative of the bottom and try again. But what happens if I try again? Cosine of 0 is 1. Please know your unit circle. Oh my goodness, we should go again? Yes. Je ne comprends. Derivative of 1 is 0. Derivative of negative cosine is negative sine. All over 6x, which is also 0 over 0. I'm done. No, you're not. One more. Don't you see what's happening to the denominator? It's not a 0 anymore. Why am I going to write an equals and why am I going to write a 1/6 and be done? Because when you plug in 0, cosine's 1 and 6 is 6 and that's a number and I'm done. What if I had tried L'Hopital's one more time? Negative sine over 0. If you do L'Hopital's when you're not allowed to do L'Hopital's, you're going to make it wrong. Can only use it when it's legal. But this gets a number and I'm done. Dun, 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 dun. What about this guy? If I plug in, don't I get 1 over 0 minus 1 over 0? Infinity minus infinity, is that good? Can I just say 0 and be done? No. Now technically, if we were to think about, isn't this cosecant? And doesn't cosecant bounce off of sine around the axis? Wouldn't this limit not exist like d and e because as it comes to 0, it doesn't agree? Doesn't 1 over x do the same thing? Guess what? To make this legal, it actually needs to come from a side. Let's make it go from or towards 0 from above. Okay. Otherwise, it'd be dne minus dne, which doesn't work so well. But if I'm coming from above, that'd be positive infinity minus positive infinity. Guess what I don't know? Look at your card. That's indeterminate. I need to know who's stronger. Who's stronger, cosecant or 1 over? I don't know. So what are we going to do? Come back to L'Hopital's and make a note of make a note of these first two indeterminates. If we get any of these, guess what we have to transform the function to look like? A 0 over 0 or infinity over infinity, because I can't do L'Hopital's unless I have a top and a bottom that is giving me an indeterminate. These say indeterminate, but I have to transform them somehow to be able to use L'Hopital's. Transform, how can I? Hey, do you guys know what I'm doing if I do something like this? I got a common denominator. I multiplied him by x over x, and I multiplied him by sine over sine. And all of a sudden, I have an f and I have a g. So then, guess what I'm going to do? L'Hopital's. And L'Hopital's, I'm going to get, nope, derivative of sine is cosine. I know it's not quotient rule, but it's supposed to be easy. Derive the top, derive the bottom, but he's not easy because he's a... Oh well, do what you gotta do. Second d first, plus first d second. Plug in. 1 minus 1 is 0 plus 0 is... Well, I wonder if eventually this is going to work out. Because the derivative of negative cosine is a positive sine, and a derivative of sine is a cosine, and derivative of... Do what you got to do. Suck it up. Do what you got to do. Second d first, plus first d second. Oh my goodness, you're getting good at derivatives. Go figure. Plug in. 0 over 2?
Yes, 0.
Why did I put an equals and I didn't put an arrow? Dun 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 dun. Abby. But then you would have gotten infinity minus infinity. I have to have a top and bottom, or I'm not allowed to use L'Hopital's. Does that make sense? But what about this guy? Shh. This is the guy period 1 couldn't get to. 1 plus 1 over infinity to the infinity. Wait, what happens when bottom wins? 0. 1 plus. Oh! 1 to the infinity is indeterminate. But what if we do x plus 1 over x and we do a quick little common denominator? But I get 1 to the infinity. So guess what we're going to do? We're going to say, you know what? Do you remember what we did when we had things in exponents we didn't like a long time ago? I want a limit. I want a limit. But guess what I can do? I can ln and ln, and guess where the x goes? I'm going to have fun finishing this on your video. You can check it out just like period 1 has to check it out, but at least you kind of know. See the dilemma? Bye, guys. I'll see you later. L'Hopital's due tomorrow. Fully attempted. There aren't too many crazy ones like this. Bye.
This towel. This towel. And don't forget your notebook. I'm sorry to anyone who's seen this video.
For the book, I'll give you back.
Because factor, that's why.
Bye.
What do you do when you don't know how to use factors? Factor.
Remind me tomorrow.
Oh, sorry. I'm coming. You slow down. Everything's fine with that.
Wow, that's special.
Sarah, get out.
Bye. Sorry guys, what I saw is that I brought the x outside of the limit, which is a little bit illegal. It's a little bit premature. Yeah, good. Yeah. Come back in a sec. According to limit properties, I can actually bring in the ln, and when I bring in the ln, I can bring down the x. This has to do with the limit property of f of g and g of f back to the beginning of limits. Now here's the sad part. If I plug in infinity now, I would get infinity times. Infinity over infinity would go to 1, and ln of 1 is 0. Sadly, another indeterminate. So I'm not going to plug in yet. I'm still trying to get an f over g for L'Hopital's. So to get an f over g, I'm going to actually say multiplying by a fraction is dividing by its reciprocal. Now at this point, there's good and bad to how I've written this. Because right now, if I plug in ln of degrees tied ratio of leading coefficients, which is 1, ln of 1 is 0, over 1 over infinity bottom wins is also 0. I do have a 0 over 0, ironically, which is L'Hopital's. But how do I take a derivative of that? Well, if I were you, do you love yourself? I would rewrite this guy. Because this derivative is so much easier to take when I have to derive the top to be 1 over u times u prime. Derivative of 1 is 0. Derivative of x to the negative 1 is negative 1 over x squared. That's just derivative of the top, f prime, for my f. Now looking for g prime from my g. Derivative of 1 over x is negative 1 over x squared. Check it. They reduce. We end up with the limit as x goes to infinity of 1 over 1 plus 1 over x. If I go plugging in infinity or thinking about approaching infinity, the only place x exists is right here. If x is approaching infinity, if the denominator is approaching infinity, bottom wins. This guy is approaching 0, so I can say this is equal to 1 over 1 plus 0. I'm done, except I'm not. Because what is on the other side? Who was I actually trying to solve for the entire time? If you look up above or somewhere, I'm trying to find this guy. And the way to get that guy is to get rid of the ln. So ironically, the limit as x goes to infinity of y, which is the limit as x goes to infinity of 1 plus 1 over x to the x is, which some would say is a definition, of E. So actually, in BC, we memorize this puppy. You're welcome.